Hello everyone, myself Sabina Devi, Assistant Professor, Department of Physics. In previous video, I explained about the introduction to black body radiation and Planck theory. So in Planck theory, Planck introduced so he assumed five assumptions that are so the black body, the atoms in the cavity walls behaves as oscillators, so each with a characteristic frequency of oscillation, right? So the black body, so it will not emit energy, emit or absorb energy continuously, so only in discrete values, okay, so called quanta, okay. So the energy is equivalent to h nu, so E is equivalent to nh nu, so n is nothing but quanta number, h is Planck's the constant, and u is the frequency. So while temperature is high, the energy density also very high, okay. So these parts will these parts are explained in previous video. So now I am going to explain about the now we are going to derive the derivation part, okay. So here we are going to derive the average energy of the black body radiations, okay. So first of all, average energy of the black body radiations. So consider a hollow cavity at temperature T acting as a black body. So the walls contain a large number of atoms, atomic status vibrating frequency. Okay, so the quantization of energy is equivalent to, according to Planck's theory, the allowed energy levels of oscillators are E is equivalent to nh nu. So average energy of the oscillator is, so the using Boltzmann distribution law, so E is equivalent to h nu by so E bar, average energy is E bar is equivalent to h nu by e power h nu by kBt minus 1. Okay. So the derivation next is Planck radiation's law. So the density states, okay, so let us consider the two density states, so two regions, okay, so nu and nu plus dV. For dV interval, so we have take the two frequency levels, okay. So in this frequency level, the density states are 8 by nu cube by c cube into dV, okay. Finally we will derive the energy density. So by synthesis of the density states with the average energy per oscillator, the Planck formulated his revolutionary radiation's law. So combining density states with the average energy per oscillator yields the energy density expression. So u of v comma t into dV is equal to 8 by h nu cube by c cube 1 by exponential of h nu by kt minus 1 into dV. So this profound equation stands as the definitive Planck's radiation's law. So accurately describing the black body spectrum across all the levels, okay. So the significance is it explains black body radiations completely, okay. So next the resolving the, so next actually the significance is, so it explains the black body radiation completely. It avoid ultraviolet catastrophe. The Planck's quantization hypothesis provided a precise resolution to the long-standing problem of the ultraviolet catastrophe, okay. The classical Rayleigh-Jeans law explained the predicted infinite energy output at the high frequencies, a phenomenon dubbed the ultraviolet catastrophe. Crucially, the Planck's law demonstrates the remarkable agreement with the experiment observations across the entire electromagnetic spectrum, so the validating its accuracy. So this is the one of the significance of Planck's theory. So it is the basic foundation of the quantum mechanics. These are all the significance of quantum theory. So the limitations are, so it examining the Planck's radiation's law in its limiting case reveals its compatibility with the earlier empirical laws. So the low frequency regions, for the low frequency region, so according to the Rayleigh-Jeans law, so we will get the Planck's radiations simply to the Rayleigh-Jeans law. So in Rayleigh-Jeans law holds good only for low frequency regions, okay. So u of v comma t is equal to 8 by nu square kt by nu cube, okay. So for high frequency law, so it conversely the high frequency limit, it converged into a Weins approximation. Okay, so Weins displacement law holds good only for longer wavelength region. So U of V comma T is in directly proportional to the nu cube e power minus h nu by kpt. Okay, so the Rayleigh Jeans law holds good only for shorter wavelength region. So Weins displacement law holds good only for the longer shorter wavelength region. Okay, the Planck's law elegantly unifies both these empirical regimes and demonstrate to the universal applicability. Okay, so these are all the limitations. So the prefound significance we will learn about. So it is the foundation to the quantum mechanics. So the birth of quantum mechanics in 1900. So it has it clearly explained the energy was not continuous. It has discrete of energy levels. Okay, so each energy levels, each atoms in the each energy level absorbs the packets of energy is equivalent to h nu. Okay, so it is the foundation for modern statistical quantum mechanics. So key references are, so these for those wishing to develop deeper into the Planck's theory and its implications, the following references highly recommendable. So these are the reference for the future further readings. Thank you all.